Hello everyone, in this video I describe the table method for finding the limits. In the previous video we did use the graphical method to find the limits. Alright, so in order to use the table method, we just choose the different values of x near the neighborhood of given number, and then we see how the value of fx changes. In the first example, we notice that if we try to plug in, so limit x approaching to 2, and we are given this function over here. So if I try to plug in the value 2, so what do I get? 3 times 2 square minus 5 times 2 minus 2 over 2 minus 2. So we get on the top 12 minus 10 minus 2, and on the bottom we get 0. So 12 minus 12, so on the top we have 0, on the bottom we have 0. So we got 0 over 0 form. So this is indeterminate form. Indeterminate form. So it means we need something else. We cannot solve this problem by just plugging in the values. So we need something else. And also we notice that the function is not defined at x equal to 2. So whenever a function is not defined at a certain point, so it doesn't mean that the limit does not exist at that point. So the limit might still exist. Essentially for the limit, we are looking what's going to happen in the neighborhood of 2. So what's going to happen when we go really close to 2. So let's see what happens in this case. So we need something else. So let's try to use the table method. So few advantages of table method are that it always works, and the disadvantage is that you have to do a lot of calculations because you have to choose different values of x and have to find the corresponding y values or the corresponding function values. So I have set up a table here. So on the first row I'm going to write my x values that I'm going to choose in the neighborhood of 2. So we're going to start with 2, and we are interested in so finding what's happening when we approach 2. So at 2 it's undefined indeterminate form, so we don't know, but let's see what happens in the neighborhood. So I'm gonna choose some values to the left of 2. So you can start with like maybe 1.9, or you can go really close to 2, more closer and closer in each step, and then we see what happens to the fx. So when we choose x is equal to 1.9, so we get 6.7 for our function. Similarly, when we choose 1.99, we get 6.997, and when we go further close we get 6.997, and you can even go 1.99999, and you can find the corresponding value. And let's try from the other side. So if you try 2.1, so the closer to 2, right? So 2.1, so you will see that you get 7.3, and similarly if you choose 2.01, we get 7.03. If we go 2.001, we can get 7.003. Similarly, if we choose 2.0001, we'll get 7.0003, and so on. So the thing that we notice here is, so this from this side the value is approaching to 7, and even from this side the values are approaching to 7. So as x approaches to 2, fx approaches to 7, and we say that limit of x approaching to 2 fx in this case is 7. So our function is here. So this is limit x approaches to 2 fx, and this is what we were trying to find. Right, so let's take a look at another example, and we're going to use the table method again. So let's see what happens in the next example. For the second example, so we are trying to find what happens when limit x is approaching to infinity and the function is defined by 3x minus 5 over 4x minus 7. So first thing we always do for the limit questions is we try to plug in the values and see what happens to fx. So if I put x in the numerator, we get a really big number, infinity. If I put x in the denominator, again we get infinity. So this is again an indeterminate form. So it means we don't know really what the value is. So I just want to point out, so just make a note that infinity over infinity is not equal to 1. Similarly, 0 over 0 is not equal to 1. So don't think that your answer should be just 1. So in this case, so again, I have already set up the table here in which we're going to plug in the values. So how we're going to choose the values? So one thing is, whenever we have really large or really small number like infinity and negative infinity, we do not look at the both sides of infinity, because if you look at infinity from the negative side or the positive side, it's no matter what you do, it's going to be a really large number. So essentially what we do, we just look at the one side. So if x is approaching to plus infinity, we're gonna like keep increasing the values of x and see what happens to the y values. If x is approaching to negative infinity, we're gonna keep making the x values really small and see what happens to fx. So an overview of the table method. So what we learned from the past two examples is, when x approaches to plus or minus infinity, so you only have to look at one side, and we use the table method for the cases of 0 over 0 or infinity over infinity when we have indeterminate forms. Thanks for watching. In the next videos, I will explain the algebraic method and the limit rules by Cauchy. So it will take me a couple of videos to explain everything in detail. So please do keep watching my videos.